Assalamualaikum and a very good day to all lecturers. So today, my groupmates and I will present our open-ended laboratory proposal regarding batch reactor. So let's move on to the next slide. So the following are the contents of our presentation for today. So let's move on to the next slide.
First of all, we would like to introduce our project for open-ended laboratory, which is batch reactor. Batch reactors are tanks that are widely utilized in the chemical industry from the lab to the plant floor. In a batch reactor, high conversion can be accomplished by allowing the reactant to remain in the reactor for an extended time. The batch reactor is often operated isothermally and at a constant volume to make ethanol and sodium acetate by hydrolyzing ethyl acetate with sodium hydroxide. The process is referred to as a saponification reaction. Chemicals such as sodium acetate and ethanol, which are end product of the saponification reaction, are employed in a wide range of applications including the oil and textile industries. So a second order reaction model is used to describe the ethyl acetate hydrolysis. Our project goal is to examine the performance of the batch reactor for sodium hydroxide based ethyl acetate hydrolysis, and the temperature was a factor in evaluating the batch reactor performance. Thank you, and I would like to pass to my colleague. This is our schematic diagram for our batch reactor.
So for the next part of the presentation is the objectives, variables, and hypotheses of the open-ended laboratory experiment. So for the objective of the experiment is to determine the optimal condition of the product yield. For the manipulated variable, it is the reaction temperature, which is from 293 Kelvin to 313 Kelvin. Next is the responding variable, which is the completion time of reaction. Next is the constant variable, which is the agitator speed, which is set to 130 rpm, the concentration of sodium hydroxide and also ethyl acetate, which is set to 0.5 molar. And lastly, the experiment hypothesis. For the hypothesis, as the reaction temperature increases, the completion time of the reaction based on the concentration of sodium hydroxide decreases. So that is all. I will pass the presentation to my colleague. Thank you to my colleague for the previous explanation. So now, I will continue to present on the methodology. So the first step is to fill the reactor with 0.7 liter of sodium hydroxide and ethyl acetate with initial concentrations of 0.05 molar for both reactants. The agitator speed is set to 130 rpm using the speed selector switch. Then the temperature is set to 293 Kelvin for the initial reaction mixture temperature. Then the conductivity meter is observed at 4-minute intervals until the reaction is complete and the data is recorded. For the final step, step 1 until step 4 is repeated, however, using reaction mixture temperatures of 298 Kelvin, 303 Kelvin, 308 Kelvin, and lastly 313 Kelvin. So I will pass the presentation to my colleague.
Next, I would like to point out all the safety and precaution for this open-ended lab project. First of all solutions should be prepared accurately and must be standardized. Titration should be carried out precisely. The individual reactants must be first preheated to the reactant temperature. While taking sample, care should be taken that tip of the pipette does not touch the agitator blade. For setting of reaction temperature, initially the temperature should be set less than 293 Kelvin to avoid overshooting. Before starting the flow rate of ethyl acetate, temperature should be set at desired temperature. All the glassware to be used should be properly rinsed prior to use. These are the basic precautions before, during, and after the experiment, from personal protective equipment to waste disposal. Next is ventilation controls, and for additional precautions, avoid skin or eye contact with chemicals and breathing fumes. Remove clothing if contamination happens, and wash before reuse. Replace contaminated gloves with a new pair. Thank you from all of us. That's all for our presentation today for our open-ended lab project.